Hello, you beautiful people. This is Computer Science for Everyone, episode 10, and we're going to talk about iteration. Remember, we talked about two important building blocks of any algorithm. One was sequencing, and the second one was selection. And remember selection. There are some points, we make a decisions. The outcome of decisions let us know which way we want to go. Okay, sometimes decisions are binary, yes, no. Sometimes we use else if to have multiple branches and options. Today, we're going to talk about something very important. Repeat or iteration is very, very fundamental in any almost applications, and not only in the computers. When you look at technology and all the time, especially industrial revolution, one of the nice things that we could expect from machine was being able to repeat things. When you look at the fan, is repeating one cycle. Look at everything, washing machines, all of them, they keep repeating things. But there are criteria. For example, when you look at washing machine, you're not going to repeat forever. Then you're going to run out of money for paying your electricity bill. But there is a criteria for the machine. How long continue? Maybe 5 minutes, maybe some other criteria. So this concept of loop is important. When you look at softwares and applications, you see them again. When you look at the Google search engine, you write something in query, Google will go through the database of the website that they have, indexed database, and they go through all of them one by one. It's a loop, checking. Same thing happening in a cycle with different websites, and then you see the result. Computer games, robotics, everywhere, you see repeat and repeat and repeat. So it's very important to see how we can utilize the concept of the repeat and then bring it to our algorithm to make them faster, smaller, and less boring. That's what we're going to talk about it today. Okay, the first example that I'm going to talk about it, I think that's the only example I'm going to talk about it, is drawing a square. It's really nice when you look at geometry or look at the life and art. There are a lot of repetitive patterns. And that's why I picked up this one, because it's very, very close. Everyone can feel it, can experience it. When you want to draw a square, what do you do? Typically, you start to draw a line. You have to know what is the side of a square. Let's say is 10 centimeters, right? So you have to draw one line 10 centimeters, and then you have to turn right 90 degree, draw another line 10 centimeters, turn right 90 degree, draw another line 10 centimeters, turn another 90 degree, draw a line 10 centimeters, turn right another 90 degrees. So you look at what I've done just now, draw, turn, draw, turn, draw, turn. 4 times, I'm repeating this pair of tasks. Draw a line and turn right 90. So then you're going to have a kind of a score. A score, it's explicitly, you can see what is getting repeated here. So for doing this one, I designed a flowchart. Let's see the flowchart first. So now look at this flowchart. It starts from here, and the first line, I have draw line for 10 centimeters. But from now on, I like to call it like a function, draw line 10 centimeter. Technically, these two are the same, but this is a little bit of more pseudocoded style. Draw line 10 centimeters, then turn right 90 degree. Then after that, again, draw line and then turn right 90 degree. Draw line 10 centimeter, turn right 90. Draw line 10 centimeter, turn right 90 degree. So you know what? Even when I wanted to draw this flowchart, I first did the first 2 blocks. I copy and then paste 4 times because I don't want to do that. It's boring. This way of thinking and solving the problem is not good. Don't do this at all. What if I'm going to ask you that instead of a square, go for hexagon? Then you're going to have 6 times of these blocks. 12 blocks. What if I'm going to ask you go for octagon, 8 sides? This is not the solution. You are in charge to come up with the kind of fantastic, smart algorithm that can draw any kind of polygon or a square in my example. This is not the way that you're going to do that. You don't like this approach. So let's look at the flowchart again one more time. But we see what is happening here. We can see that the first 2 blocks are keep repeating. And now we have this question. How we can ask this flowchart, that's the challenge. Not do this 4 times, to just keep only 1 time, repeat this 4 times. So we have to do some magical things in the flowchart to be able to show this concept of iteration. So 2 things we have to consider. One is how to what kind of changes we have to do in our flowchart to be able to repeat something, because there's a part of flowchart we want to repeat it like a loop. So we want to repeat it. And number 2 is how we can control to repeat it only 4 times. How we can make a decision that's enough, go and continue. In your real life, we do this. For example, let's say you're baking a cake and then you put in the oven and then 5 minutes later you're back and then check. If the quality is not yet good, you go and then 5 minutes later, until the cake is ready, you're going to stop. So there is a loop. You'll keep repeating, but there is a criteria until when. And I'm going to use that concept to first build a construction in my flowchart to be able to show the iteration. Then I'm going to answer how we can count how many times we have to do this. So first, look how I use the previous episode selection to build a loop concept in my flowchart. So look at here, everyone. Here we do have a nice flowchart here. Start from here. Then look at what I have here this time. I have only two blocks here. So one is draw line 10 centimeter, turn right 90 degree. Then I have selection. Remember, diamond is selection. We need a magical criteria here. And if the answer of the criteria is no, then we're going to just back again to this step. If the answer is yes, we're going to go out. For now, forget about what should be here, but try to understand the loop. It's so beautiful, right? We just created a loop without bringing a new concept. We just use selection. But this time, one branch of selection returns back again to some steps before. So technically, we create a loop in this way. Try to pause and think how I did this. In previous examples, we never back again to this point, but in this way, we build a loop. But if you do this one, you don't know when you want to go to the yes because you don't know what to do, and it's going to be a kind of infinite loop. So now what I like to do, I want to see what should I do? What sort of criteria or condition I have to add to my selection to stop this, infinite loop. So you got it? That's what we have to do that. So to do this, we need a way to count, because in a score example, we need to do this 4 times. This loop should be repeated 4 times and then go out. So it's very clear when and how we're going to stop. But how we can count? We need a counter. Its job is just counting. This counter, before we start the flowchart, before we start the algorithm, the value is 0. Its value is 0. When we draw one line and one turn right, its value will be 1. Good. And 1 still is not 4. So we repeat again. Draw another line and turn right, then this value will be 2. Well, 2 still is not 4. So again, the third time, 3 is not 4. The 4th time, so every time we count by 1, 2, 3, 4, I got a 4, so then enough. I don't want to continue because I'm supposed to draw a score, and then I continue the rest of algorithm to reach to the very end. So in next flowchart, I completed and I added that mechanism. Let's see how it's going to work. Okay, now look at this, everybody. Here in this yellow box, I created a variable. Look at the name of the variable, number sides plotted. So in computer, there are different ways that we choose name for a variable. When a variable has multiple names, multiple words, we may use like what I did, underline between them. Sometimes we connect them, we make the first letters uppercase, we call it camel case. I'm going to talk about these stuff in the coding part. But remember, variable is just temporarily way that you can hold the value and then you can manipulate it and work with it within the code and then refer to that value in an easier way. So if you look at the flowchart here, I created this variable and its initial value is the 0. This is actually the counter that I just talked about it. So let's go through the flowchart. Draw a line, turn right, and look at what I'm doing here. This is very interesting. I update the value of our counter by increasing 1 unit. So I'm incrementing 1 unit. Number sides plotted, which already is 0, plus 1, return it back, assign it back again to variable itself. This is a common way that we can update a variable itself in coding. That means the variable name, like number sides plotted, equal by number side plotted plus 1. So the assigned equal operator is assignment. How computer thinks, computer first look at the right side, evaluate the right side, then whatever is evaluated the right side, assign it to the left side. So look at the flowchart again. Because this wrapped, the text wrapped, but technically this is the right side. So first variable is 0. 0 plus 1 will be 1, and 1 will be assigned back to number side plotted. So after this, number sides plotted will be 1, which is true. And then we come to the decision. If it is 4 or not, or no, or not yet, it's just 1. So we're just going to back again here. I'm going to draw again, turn right again, and then number sides plotted, which already is 1 plus 1, 2, then will be assigned back to variable itself. So now it's 2. Is 2 is equal by 4? No, it's not. So I repeat again, draw the third side. So 2 plus 1, 3. You can see that at the end of each cycle, number sides plotted after getting update will be equal by the number of times we repeated the loops. That's nice. So number sides plotted is 4. No, it's 3. So no, we're back again here. And then number sides plotted 3 plus 1, 4. And it is equal by the 4. Yes, it is 4. So we're going to get out of the loop and then go to the end. So make sure pause this video here and then go through the flowchart. Definitely you're going to get it. It's not difficult. But that's really interesting. We use selection, we use a counter, and now we're managing 4 times iteration. I also route a pseudocode. I want to show the pseudocode with you guys. So look at this simple pseudocode. It's just a way that we draw the score. Instead of the draw line, I use a famous function in Python, Turtle, forward, and 100 is 100 pixel. Because in monitor, we don't talk about a centimeter. We can, but let's call it pixel. So, but you can think of draw line 10 centimeters, so not different. So forward, then right 90. Forward, then right. Forward, right 90. For 100, right 90. You know, this is the way that you can imagine a kind of a score. So no matter where you are standing in your room, if you follow this one, imagine forward, 100 centimeters or 100 pixels, and then turn right, and then again forward, and then turn right, and forward, turn right. You're going to have a kind of a score. So this is without iteration, without loop. So let's look at it again. Now I'm going to go to do pseudocode and bring the iteration. So look at this one. In first line, I created a counter, count equal by 0. So this is very similar to this number size plotted. So then now here I do have a new term, do while. Do these 3 lines of code, you see the indentation? Do these 3 lines of code while this criteria is true. As long as count still is not 4, do these 3 lines. And what are these 3 lines? The first and the second are exactly what we are repeating here. So we found which one we should hold and repeat it 4 times. And then there is a count, updating the count variable. Count equal by count plus 1. Remember, we computer first evaluate the right side. So if the count is 0, 0 plus 1 will be 1, and 1 will be assigned back to the count, and count will be 1. And this will be repeated till while count is not 4. So technically means 4 times. And then finish, and then back. So this was iteration. I want you to pause the video, try to understand. If you have questions, ask me later. But it's very important that you get the sense of how this algorithm, how we could bring iteration to our algorithm. And that was the whole thing. So again, remember, 3 building blocks: sequencing, selection, and iteration. Technically, we build iteration using sequencing and selection. That's a very important thing. So you can think of maybe only 2 concepts enough: sequencing and selection. You're right. Technically, that's how we build deep down in the computer iteration, by jumping back to a point that we have been there before based on a condition. And Alan Turing machines, the first version of the computer, also was using this concept. Okay, everybody, this was iteration. I hope you enjoyed and find some kind of skills to avoid boring, repetitive tasks in your life, and try to go through all the kind of flowcharts by yourself, and see you in the next episode. Happy iterating.